Welcome back to Networking Fundamentals by Yamaha Commercial Audio Systems. I'm Pat Kalani. In prior videos, we covered the fundamental settings of any network device: IP address, subnet mask, gateway, and DNS. In this video, we'll cover some protocols that help you make these settings automatically anytime a device joins the network. Specifically, we're talking about DHCP and link local. DHCP, or Dynamic Host Configuration Protocol, is probably the most commonly used method of joining networks. It helps us automatically configure all the core settings: IP address, subnet mask, gateway, and DNS. When we're using a DHCP server, we're usually trying to take a number of network devices and put them in the same pool. As such, the only thing that's going to vary from device to device is the IP address. The subnet mask, the gateway, and the list of DNS servers will be identical from device to device. Now, because the DHCP server usually resides in the router, it already knows many of these settings. So most of the time, the settings you need to make for a DHCP server really circle around the IP address. First, we have to establish a DHCP range. This is a list of IP addresses that the DHCP server is allowed to hand out. In this example, we're going to give it a range of 192.168.1. Anything between 101 and 250. The next setting is the DHCP lease time. Effectively, when the server hands out a configuration, how long is it good for? Most servers default to 24 hours, but you can change that. Now, the best way to really understand these settings is to look at the mechanics of a DHCP transaction. Let's go through that and see if we can give you some insights. When a computer wants to join a network using DHCP, it needs to get a message to the DHCP server requesting a configuration. Now the problem is, this computer knows nothing about the network, so how can it find the DHCP server? Well, it starts out by sending out a special type of message called a broadcast. When a network switch receives a broadcast message, it propagates that message to every port on the network. Now, most network devices will just ignore this, but the DHCP server will respond with a configuration for that device. Now, hopefully we've made clear that devices on the network have to have unique IP addresses, right? You can't have duplicates. So you'll notice that the DHCP server is making a note of the IP address it handed out, the MAC address of the device receiving it, and we'll get into that in a moment, and it makes note of the expiration. So this IP address could be freed up for somebody else to use in the future. Let's walk through this exchange a few more times as a few more devices join the network. Here we have a smartphone. It wants to join the network by DHCP, so it sends out a broadcast message. The DHCP server responds, giving it a configuration. A laptop wants to join the network and does the same thing. It sends a broadcast message. Only the DHCP server responds with a configuration. Now, it's worth pointing out that we do not maintain a connection to the DHCP server the whole time we're on the network. To use a phone analogy, once we've received our configuration, we say thank you very much, we hang up the phone, and we go about our business on the network. So let's take a look at the mechanics as devices leave and rejoin the network. Well, let's suppose that person with the smartphone leaves for lunch, and when they come back, they take their smartphone and reconnect it to the network. Even if the phone remembered its configuration from before, it can't be sure that this is the same network. Just to be safe, it starts the DHCP process all over again. So it sends out a broadcast message. The DHCP server will respond with a configuration. Chances are the DHCP server would have noticed this is the same phone that was on the network an hour ago. It would know that by the MAC address, and we're going to get to that in just a moment. But based on that information, it would probably take this phone, put it back at the same IP address it was at before, and re-extend the DHCP lease. Now here's another example. Let's suppose that laptop leaves the network, and it leaves for good. Remember, the DHCP server does not have a connection to all devices on the network, so it's unaware when devices leave. If you look in the table, you'll notice that the IP address will still be reserved until the lease expires. So, when another device joins the network using DHCP, it sends out a broadcast message asking for a configuration, and the DHCP server responds. So you'll notice this computer got a fresh address from the range of DHCP addresses. Again, even though the laptop isn't on the network anymore, the DHCP server doesn't know that. Its address is still reserved until the lease expires, so the DHCP server went down and picked a fresh address from the pool. So now let's fast forward to the next day. Let's suppose that first computer is still on the network when its DHCP lease is set to expire. So what does it do? Well, it contacts the DHCP server and says, hey, I need to be on the network. Can you give me a configuration? And unless you've changed the configuration on your DHCP server, this device will get the same configuration it had before. So there's good reason why the DHCP server tries to keep your IP settings consistent. Let's suppose this network device was in the middle of a download, or it was streaming content when the DHCP lease expired. If the DHCP server was to issue a completely new IP configuration, then any of these processes would be interrupted. However, if the DHCP server effectively just renews the lease, keeping all of your settings the same, these processes continue completely unaware that anything has changed. Now, the way it tracks devices is by the MAC address. We've mentioned that a few times, so let's talk about that now. So first of all, what is the MAC address? Well, it's the machine address code. Now for the grammar sticklers out there, I know when I say MAC address, I'm being redundant, right? It's machine address code address. I have a streak of that myself, so I can relate. But most people in the industry will say MAC address just so they're clear they're not referring to the Apple computer platform, the Macintosh computer, right? So the colloquial way to say this is the MAC address. So every network interface has a unique machine address code, and it's usually expressed like you see it on the screen right now. It's 6 hexadecimal bytes. The address is hard-coded on the chip that runs your network interface. So generally speaking, you can't change it. It's permanent and it's unique. Most people think of a MAC address like a fingerprint. It's hard-coded, I can't change it, and it's unique to me. My fingerprint is different than yours. So we can use the MAC address to uniquely identify devices on the network. The general rule of thumb is that if a device takes an IP address, then there's also a MAC address at work. Now, it's worth noting that devices can have multiple network interfaces. There's a lot of Dante devices that fall under that category, but also most laptops will do that, right? We'll have a wired network interface and a wireless network interface. So in that case, each network interface may well have its own MAC address. So keep that in mind when you're setting things up. Now MAC addresses can be used in a lot of ways, but here we're going to talk about using it with a DHCP server. The DHCP servers in most routers today will give you the ability to permanently correlate an IP address with a MAC address in the DHCP table. Now different manufacturers will call this different things. Some of them will call it MAC binding, they might call it MAC reservations. But the goal is to give you a hybrid of the benefits from DHCP and static IP. A device automatically configures itself on the network, but you know what IP address it's going to have in the end. Let's take a look at how this works. Here we have a printer that we've set to join the network by DHCP. We want to know that it will always show up at .51 on our network. So we've taken its MAC address and associated it with the IP address .51 in the DHCP table. The printer will follow the DHCP protocol. It will send out a broadcast message looking for a configuration, and the DHCP server will find this permanent correlation in its table and give the IP address of .51. Now in my experience, most DHCP servers that support this feature will allow you to pick IP addresses that are outside the DHCP range. Just a little note for you. Now, we've covered DHCP servers pretty well, so let's move on to a troubleshooting topic. Let's suppose I set my device to get an address by DHCP. What happens if there is no DHCP server on that network? The answer is that it will probably revert to a protocol called link local. Link local is a simple protocol allowing devices to join a network, get a unique IP address, and still be able to communicate with other devices that joined by link local. So link local starts with some simple assumptions. We're going to pick an address in the range of 169.254.anything.anything, and we'll assume a subnet mask to go with that, 255.255.0.0. Now, because there was no DHCP server, it's probably a safe bet that there's no router on the network. So we're not going to attempt to set anything for the gateway, and we're not going to try to build a list of DNS servers. So DHCP diagrams tend to look like this. The DHCP server usually resides on a router, so that brings with it the firewall, right? With link local, we're clearly only concerned about a local area network. There's no firewall, there's no wide area network. Let's suppose this phone wants to join the network using link local. It's going to pick an address at random that is in the link local range. It will then send an ARP request on the network to see if anybody is using that IP address. So in this case, there's a computer that's already using this IP address. So it responds to the phone and says, yes, I'm already using it. Please try again. The phone says, okay, I'll pick another address at random in the link local range, send out an ARP request and see if anybody responds to that. This time, nobody responds. The phone assumes that's because nobody has this IP address, therefore it must be available, so the phone assumes it. Well, that about wraps up this topic. In this video, we covered the mechanics of DHCP servers. We talked about MAC addresses and how we can use them to pin IP addresses in our DHCP server if we so desire. And we talked about link local and how some devices will use that as a backup to DHCP if the DHCP server isn't present on the network. Thank you for joining us for this series on networking fundamentals, and I welcome you to keep an eye out for our next video series, Intermediate Networking Skills.